Hello friends, my name is Vishaya Rathod. Today we discuss about Naïve classification, a comprehensive overview. Welcome to this presentation. Naïve classification is powerful probabilistic method for predicting the class of data point based on its feature. Join us, we will explore its underlying principles, assumptions, and practical applications. Introduction to Naïve. Naïve's classification is a supervised learning and algorithm based on Bayes' theorem, a fundamental concept in probability theory. This algorithm makes probabilistic prediction by calculating the probability of data point belonging to a specific class based on its feature. Classification assigns data point to predefined classes, predict the category of new data point belong to. Probabilistic utilize the probabilities to measure the unlike of data point belonging to particular class. It estimates the probability of each class. Supervised learning. Learn from the labeled data, require training set with known features and the corresponding classes. Underlying assumptions. Naive relies on several key assumptions that simplify the classification process. These assumptions allow algorithms to efficiently calculate probabilities and make prediction. Feature independence. The algorithm assumes that the features are independent for each other. This means that the presence or video of one feature do not affect the value of other feature. Class conditional independence. Given a specific class, the algorithm assume that the features are independent of each other. This means the features are independent of each other within each class. Equal prior probabilities. The algorithm assumes that R class have equal prior probabilities. This means that each class is equally likely to occur before supervising any data. Bias theorem. At the heart of naive bias is bias theorem, a fundamental principle of probability theory. This theorem provides the way to calculate the probability of event given prior information. P of B by A, the probability of event occurring given that event B has already occurred. The probability of event occurring given that event A is already occurred. P of A, the prior probability of event A. P of B, the prior probability of event B. Calculating probabilities. Naive Bayes calculate the probabilities of classified data points. These probabilities are calculated using the feature of data point and the probability learned from the training data. Pure probability. Probability of each class occurring in the training data. It represents the baseline probability of class. Likelihood probability. Probability of arising the feature of data point given a specific class. It measures how well the features match the class. Posterior probability. Probability of data point belonging to the specific class given its feature. It's calculated by the combining prior and likelihood probabilities. Feature independence assumption. The feature independence assumption is crucial aspect of naive bias. This assumption simplifies the calculation of probabilities by assuming These features are independent of each other. Advantage: simplifies calculation and reduce computational complexity. Computational complexity. Complexity simplifies the calculation and reduce computational complexity. Complexity simplify the calculation and reduce computational complexity. Limitation may not be accurate in real-world dataset where features are often correctly corrected. May be not accurate in real-world dataset where features are correlated. Training and prediction. Null bias is trained on dataset with known features and class level. This training process enables the algorithm to learn the probabilities needed for prediction. Training phase. Learn probability distributions of features of each class. Prediction phase. Calculate posterior probabilities for each class using Bayes theorem. Classification. Assign the data point to the class with the highest posterior probability. Advantage and limitation. Naive bias has both strength and weakness. Understanding this aspect help us to determine when to use it and when to consider alternative approaches. Advantage: simple and easy to implement, fast and efficient for prediction, work well with high dimensional data. Limitation: features independent resistance can be unrealistic, sensitive to data slightly and imbalanced datasets, may perform poorly when features are highly correlated. Application and use case. Naive finds the application and diverse domain, demonstrating the versatility and the effectiveness its strength and handling the text data make it particularly popular for text-based application. Spam filtering. Classifying mail and spam are not spam based on the content and center. Sentiment analysis. Determining the sentiment expression and the types of whether the positive and or negative or neutral. Document classification. Categorization document into different categories such as news, sports, or finance. Medical diagnosis. Prediction like likelihood of diseases based on symptoms and medical theory. Thank